So in part E, we are told that with the capacitor still charged as in discussed in part D, the switch is now moved back to position A. We need to express our answers in terms of R, C, and Q. And in part 1, we need to derive an expression for the current from the battery immediately after the switch is close to position A. So again, we will have to make use of Kirchhoff's loop rule. Now it's in A. We can again make this loop. So initially we will have the EMF over here, and then we will have the two resistors, which have the potential across them will be I times R. We have some current times R over 2, as that's their resistance as they're in parallel. And from this we will subtract the capacitor's potential, which will be Q0 over 2C, as that is its capacitance here. And therefore, and by definition, this is equal to 0. So all we need to do now here is rearrange for the current, and we can note that the EMF here is simply going to be the initial voltage, which is provided by the capacitor, which will be Q0 over C. So from this we subtract IR over 2 minus Q0 over 2C. This will be equal to 0. And if we rearrange this for the current, then we will get that this is Q0 over RC. And in part 2, we're asked that what is the current as time goes to infinity? And well, by definition, this will have to be 0, as simply the capacitor will build up its charge, and therefore the current will approach 0, as we have discussed in part B as well.